What's up everyone, in this video we're going to see how to deploy the Big IP F5 as a load balancer for a web application running on 3 servers. As we can see from the diagram, we have 3 servers and they are hosting a web application, and this web application is going to be requested by the client, and we want the requests to be load balanced between 3 servers, and we're going to do that by using Big IP F5. To make it easier to understand, I brought this diagram here. So essentially there are 3 main components. So we have a node, a pool, and virtual server. So let's start from the first one, and that's the node. A node is a representation or a logical representation of a server that exists in the network. So, for instance, we have 3 servers here. It means that we'll create 3 nodes on Big IP or F5. So it's just going to be the IP of these servers. A pool is going to be a service that exists or is running on these nodes or servers. So it can be HTTP pool, meaning the HTTP service is running on these servers. Can be SSH pool, means that we have SSH service running on these servers, and so on. Finally, we have the virtual server. The virtual server is the IP that the clients will use to reach the web application, and this virtual server is tied to a pool. So let's go once more. So we have a node, and a node is a logical representation of servers that exist on the network. We have a pool that are used to represent a service that is running on a node or a server. We have a virtual server, that's the IP that the client will use to access the web application or the resources that are being exposed by the nodes using the pool. Okay, it's just that simple. Okay, so let's see how to build these components. I'm going to log in again, and I'll try my password. So it's admin, type the password. So we're going to begin with the node. So we go to local traffic and nodes, and we're going to create the first node. So the name is going to be server 1. The IP it's 172.16.101.1, and I want to repeat this because I want to add others. So it's going to be server 2. The IP is going to be 170.16.101.2. Going to repeat once more, and the last one is going to be server 3, 172.16.101.3, and we're going to click on finish, and we have 3 nodes that represent the 3 servers that we have on our network. Okay, so now let's create a pool, and for this case going to create a HTTP pool, meaning I have HTTP service running on these servers. I'm going to create now, and I'm going to name it HTTP pool, and I want to add the members from the list, and the service is on port 80. I'm going to add this one, Now I'm going to add node 2 and I'm going to add node 3. So this HTTP pool has the members server 1, server 2 and server 3. So now I'm going to click on finish and it's done. Now I have this pool with 3 members. So F5 has a cool feature that allows us to visually identify whether those nodes are available and whether the service we're trying to create it's also available on the nodes, and that's the monitoring. So if we look at the nodes and we look at current status, it's unknown. It's enabled, but we don't know whether these nodes are really reachable or not. So to change this, let's go inside one of these nodes, and here on health monitors we want to select node specific, and I want to use ICMP, and I'm going to update, and now it's going to change its status to green, which means the big IP is able to reach the server. So we're going to do the same for server 2. Going to select node specific, going to update, and the same for server 3, node specific, ICMP, and we're going to update. So now we know that the servers are available. Now we can also make F5 monitor the service. So we go to pool list, we'll click on pool, and on health monitors we're going to select HTTP, and we're going to update. So now going back to pool list, and we can see that now the status is green, it's available. Okay, so if we try to create another pool on a service that the nodes or the servers doesn't have it running, you'll see that the status is going to be different. So the last element we need is the virtual server. That's going to be the IP that will be used by the clients to connect to this pool. So let's go to virtual servers, and we're going to create, and it's going to be HTTP VS, and the destination IP is going to be 172.16.180, and the port is going to be 80. And now let's select the pool that's going to be associated with this virtual server. So that should be here. I'm going to select HTTP pool, and we're going to click on finish. And we have our virtual server available. So we click on it. Let's look at statistics right now. So right now it's all 000 because we haven't tried to reach this virtual server yet. Okay, so if we go back to virtual servers, virtual address list, that's not where I want to look from. Yes, from here. So we can see that right now everything is 0. So let's try to initiate a connection from a client. So let me bring the client, and this client should be able to reach the IP 172.16.180. So 172.16.180. Currently we can see that the first server replying was server 1. So if we keep updating, we'll see that it will change I have the same page, but I changed just this field so that we can monitor at which server we are connecting at a certain time. And now let's go back to the statistics and let's refresh this. And let me extend this. And we can see that all these requests coming, a total of 23. So server 1 got most of the requests, and the other ones are so one request less. And we can see that the requests are being load balanced between all the servers in the pool, and by default it is using round robin, which means that for each request is going to deliver to the next available server. And there are different algorithms that can be more efficient depending on the scenario, but we don't want to go too deep right now. So you can see that right now it's working as it's supposed to. Now let's say we have another service running on the server and we have to make it available to the clients. So we can do the same steps, except that we don't have to create nodes because the nodes are the same, but we have to create a nil pool. So let's say we want to create a SSH pool. We're going to create and we're going to name it SSH pool, and I want to monitor using TCP half open. So we could use any other type of monitor just to check whether the service is available. We could create our own health monitors, but I just want to keep it simple. And we're going to select the nodes. So right now we're going to use the port 22, and we're going to use for server 1, server 2, and server 3. And we're going to click on finish. So we have SSH pool. So right now the monitor is trying to connect. So let's update this. So right now it's available. Awesome. Now let's create the virtual server for this one, and it's going to be SSH VS. And we can select the same IP, but just for easy understanding, let's create another IP. So it's going to be 172.16.122, and we're going to select port 22. And let's select the pool, SSH pool, and finish. So now we have two pools running on different IPs and on different ports. Okay, so let's get to our clients, close this one, and try to SSH to that IP, and that should be SSH. Going to use the root account 172.16.122, and we are in. So which server are we? So let's see, this is server 1. So let's look at statistics for this pool, and if we extend this, refresh, so we should only see traffic on server 1, and we can see server 2 and server 3 they didn't receive this request. As you can see, it is working as expected. Now what happens if this unit gets offline? Obviously we won't be able to access the resources on the servers. For this reason, we have to deploy a high availability solution. So let me exit from this connection So now let's bring big IP2 to the picture so that we can have a high available scenario. Now let me power on. And we will have to do the same steps like we did on previous video as to license provision, and then we're going to sync the configurations from big IP1 to big IP2. Okay, let me bring big IP2 and let's start configuring. So first we have to change default credentials. Okay, and now we have to disable DHCP on management interface. So we can do this from Linux shell. So if we type modify this global settings management DHCP disabled. Okay, and now create this management IP 192.168.143.32 and 24. Okay, so now scan this. So let me confirm that it changed already. Yes, it did. Okay, so Timos save these config partitions all. Okay, it's done. So now let's log into configuration utility 132. Okay, it's reachable, and we'll have to change the password. First my current password, no, the new one. Going to save this, and now we have to log in with the new password. Okay, let's begin the configuration utility or setup utility. We're going to click on activate. Going to pass the base registration key. If you don't know how I got the base registration key, you can watch the previous video to this video series. And now I'm going to select manual and click on next. Now I'm going to pass the license. Okay, now let's continue. And click on next. And this a little more. And we leave the default self-signed certificate. The IP it's correct, and host name is going to be LB2. I think there is a typo. Yes. Baltech.com. Time zone GMT plus. Root, we have to change the password. And leave everything default. And we'll begin the network configuration. So we click on next. Okay, we're going to click on next. We leave default everything. And the internal network configuration. So self IP is going to be 172.16.101.132. Mask is going to be 24/24. Floating IP is going to be 172.16.101.100. I believe that's 254. And VLAN it's 101, and the interface it's 12 untagged. I'm going to click on next. Now for external VLAN, so IP 16.100.132, mask is /24, default gateway 16.1, and floating IP it's 100.254. Let me confirm that. So local traffic, actually no, that's network of IP. So it's 172.16.100.254. Yes, it's correct. As for VLAN, that's going to be in 100, interface 11, untagged. Going to add and click on next. Now for HA, it's going to be 172.116, 172.16, 103, 132. Mask is going to be /24. VLAN is going to be 103. And the interface is 13 untagged. I'm going to click on next. Now for NTP, I'm using 192.168.91.20. Going to add. I'm not using DNS, so I'm just going to leave everything default. Config sync has to be HA interface. I will be using failover unicast configuration for these IP addresses. And click on next. Now the primary local mirror address is going to be HA. That's okay. Click on next. And now we have to select, let's see, establish an active standby pair by discovering another device. After discovering the other device, the system performs the following actions. Establish trust between this device and the peer or subordinate, creates a device group, creates a traffic group that supports an active standby configuration. So that's what we want. Click on next. And we want to discover peer or subordinate device. And we click on next. Now we have to retrieve the device credentials. It means LB1. So that's going to be peer. And its IP is 172.16.103.131. And now the credentials. And it's successful. So device certificate matches. And third step, we're going to add device to this failover group. Okay, setup utility is complete, and it's awaiting initial sync. If you look at LB1, now is on standby status, so we can change the role on this one to become the active unit. If we go to active, and we can force to standby LB2. Yes. So right now the status changed to standby. And if we look at LB1, now is the active one. So if we click on awaiting initial sync, we want the configuration on LB1 to be in sync with LB2, so we have to overwrite the configuration on LB2. We know that LB2 doesn't have any pool configured or node or virtual server, so let's sync LB2 to this group. So we're going to push the select device configuration to the group, meaning LB1 configuration is going to override the configuration on LB2. So let's sync this, and shouldn't take long. So now all devices are in sync, which means that LB2 should have the nodes and pools already configured. So let's try to log in again. And we can see we have the nodes, the pools, and the virtual servers. So let's get our client, and let's bring the page if we still have access to our virtual server. So that was HTTP 172.16.180, and it's working. Okay, so now let's fail over to LB2. So we click on active, and let's force to standby. Yes. So right now LB1 is on standby status, which means that LB2 is the active one. So if we refresh this and we look at HTTP pool statistics, actually, let me look from pool statistics and HTTP pool, and we can see now that LB2 is the active unit and is returning or handling all the requests that are destined to the server. And that's it, what I wanted to share with you guys, how to license, provision, deploy F5 on standalone and on high availability scenario. I hope you guys enjoyed, and I'll see you on the next one.